Ordered and unordered arrays. An ordered array is an array that keeps its elements in order at all times. Hence, if I want to add 34 to this ordered array, for example, I can't just put it at the back. I have to find the right position to put that 34 in. So I'm going to start at index 0 and search for the first value I can find that's greater than 34. 7 is not it. 12, not it. 14, not it. 28, not it. 39, there it is. So since 39 is at index 4, that's where I want to put 34 at. But before I can do that, I have to shift all the values from index 4 onward back one slot. I do that to create space for 34. Once I've created that space, then I can add 34 to the array. Now suppose I want to search for a specific value in the array. One advantage of the ordered array is that we could use a binary search to find that value, as opposed to linear search, which we know takes longer on average. So if I want to look for the value 14, again, the way binary search works, we start at the middle. 14 is clearly less, so we ignore 34 and all values to the right of it. We can select a new midpoint. 14 is greater, which means if it's in the array, it'll be to the right of 12. Get a new midpoint, and we found our value. Now, suppose I want to remove that value that I just searched for. Well, we know that locating the value can be done quickly thanks to binary search. However, we get no advantages when it comes to actually removing it. We still have to shift all values from index 2 onward up one slot. Thus completing the removal. An unordered array is an array that stores elements without maintaining order. So, for an unordered array, if I want to add a value to it, because we don't care about order in this case, we simply put it at the back. Now, suppose I want to search for a specific value in this array. Because the elements aren't in order, we can't take advantage of binary search. In this case, we have to do a linear search. We have to start at the front and probe each value until we find the value that we're looking for, which takes much longer on average than binary search. Now suppose I want to remove the value that I just located. Well, in this case, unordered array operates just like an ordered array, in that we will remove that value by shifting all values that are behind it forward one spot, thus completing the removal. So to summarize, for an ordered array, performing a search is much faster because we can use binary search, whereas with an unordered array, we have to use linear search. However, insertions for an ordered array will be slower because we have to maintain the ordering every time we add a value, whereas with an unordered array, we don't have to worry about the order, so we can just put it at the back. For removals, we have to analyze in two phases. For removals in an ordered array, it's slightly faster because the first phase, the location phase, can be done using binary search, whereas with an unordered array, the location has to be done using linear search. However, for phase 2 of the removal, where we actually remove the value, ordered array and unordered array are equal because both have to shift all the values behind the value that we're removing forward one spot. So, which container is the better container to use? Well, it depends on what you're doing. If you're going to do a lot of searching and few insertions, use an ordered array. If you plan to do a lot of insertions and a few searches, use an unordered array.